Hello everyone, welcome to Chemazon-Complete Chemistry. So now for today's video, we are going to solve this question 55 that was asked in JAM 2022 paper. What is the question? Let us first read the question. A galvanic electrochemical cell is made up of two cells, one is zinc and another is copper half cell that produces 1.1 volt at 25 degrees Celsius. The ratio of zinc to copper is how much? 1.0. We have to find out what? We have to find out delta G0, that is standard Gibbs free energy change when 1 mole of zinc get dissolved, and we have to find out the answer in kilojoule. Okay, and what is given, another value is given, that is the value of Faraday's constant. F is given to us, that is 96485 coulomb per mole. Now there is one more important thing to be noted. Mostly we use this value as 96500, but whenever in the question the value is mentioned, you don't have to use the value that you regularly use. Use this value only, otherwise your answer will not come in the range that is given. Okay, so let us first write down what is the given data. What is given? It is the E cell, that is the cell potential is given to us. What is the cell potential? It is 1.10 volt. Temperature is given 25 degrees Celsius. I can convert it into Kelvin. I will add 273.15. What I'll get? 298.15 Kelvin. And what else is given? Concentration of Zn2 plus 2, concentration of copper 2 plus is given, that is how much? It is 1. And what else is given? Value of F is given 96485 coulomb per mole. Okay, so we know that volt is work done per unit charge. So V is equal to W upon Q, and here we have given the charge is given, that is the unit of charge is coulomb. Coulomb I can write it as volt work done divided by the potential difference. So I can write coulomb as joule, unit of work is joule, and what is the unit of the potential difference? It is volt. So coulomb I can write it as joule per volt. Okay, why I have done this? It is easier for us while cancelling the units. So coulomb I can write it as joule per volt. Okay, now let us see how we can solve this question. Which equation we have to use? We have to use Nernst equation. Why we are using Nernst equation? Let us first understand that. What we have to find out? We have to find out delta G0. What is the formula of delta G0? It is minus NF E0 cell. We have the value of F. We don't have the value of N, that is the number of electrons involved, and E0 cell is also not known to us. So we have to find out both these values. We can get it from the Nernst equation. So what is Nernst equation? Let me erase this. What is Nernst equation? Nernst equation is E cell is equal to E0 cell plus 2.303. Okay, this is minus 2.303 RT upon NF log to the base 10 of Q. And when the temperature is how much? 25 degrees Celsius. This entire term 2.303 RT by F, if we solve it, comes out to be 0.0591. So I can write E cell as E0 cell minus 0.0591 divided by N log to the base 10 of Q. Now we want E0 cell. For that we have to find out the value of Q, and E0 cell is given to us. Sorry, E cell or cell potential is given to us. So what is the value of Q? It is the reaction quotient. It is concentration of products divided by concentration of reactants. Okay, so for that, what we have to write down? We have to write down the half cell reactions. For finding out the value of Q, we have to find out the half cell reactions. So this is which cell that is given? That is a Daniell cell that is given. And in a Daniell cell, we know that at the anode, zinc undergoes oxidation. So Zn undergoes oxidation to form Zn2 plus and it loses 2 electrons. This is what loss of electrons, so it is oxidation. And at the cathode, what happens? Reduction takes place. Copper solid, it gives, sorry, Cu2 plus, it will gain 2 electrons and it becomes copper solid. This is what gain of electrons, or we can say it is reduction. Okay, so you can see how many electrons are involved. 2 electrons are involved. So what is the value of N? N is number of electrons that is involved. N value is 2. So we got the value of N. Okay, now we have to find out Q. Okay, let me write down the net cell reaction. How do you write down the net cell reaction? Add both the half cell reactions. Okay, this 2 electron get cancelled. What we will get? Zn solid plus Zn2 plus aqueous gives, sorry, Zn solid plus Cu2 plus aqueous gives Zn2 plus aqueous plus copper solid. And how do you find out Q? Product. What is the product? Active in presence of solid and aqueous, which is the active concentration? The aqueous. Solid is not the active concentration. So we will consider only zinc and copper 2 plus aqueous form. So in product we have Zn2 plus, concentration of Zn2 plus, and in reactant we have copper. And this ratio, here you can see ratio of Zn2 plus to Cu2 plus, it is given, it is how much? 1.0. So now we have the value of Q as well. We can now find out the value of E0 cell. Okay. So let me substitute and we will find out the value of E0 cell and then we can find out the value of E cell. E cell, then we can find out the value of delta G0, that is standard Gibbs free energy change. E cell is 1.1 volt. E0 cell is, we have to find out E0 cell minus 0.0591 divided by N is how much? N is 2 electrons. Log to the base 10 of Q is how much? 1. Now we know that the log 1 value is how much? 0. So 0 into anything is how much? It is 0. So what is the value of E0 cell we have got? E0 cell is 1.1 volt. Okay, E0 cell is 1.1 volt. Now we can find out the value of delta G0. Delta G0 is how much? Minus NF E0 cell. Okay, N is how much? 2. 2 mole of electron is involved into Faraday's 96485 Coulomb. I told you to convert it into joule per volt. Okay, Coulomb per mole. This is the unit for Coulomb. This is per mole into E0 cell. What is E0 cell? E0 cell is how much? 1.1 volt. Now I had converted Coulomb into joule per volt because we can cancel volt and volt inverse. Mole and mole inverse get cancelled. We will get the answer in joule. So the final answer is going to be minus 212,267 joule. But if you see what is the final answer, we want the final answer in kilojoules. So how do you convert it into kilojoule? You divide it by 1000. So it will be 212.267 kilojoule. Now the question is, here they have told you to find out the nearest integer. Nearest integer means we have to round off to a number. So the final answer it should be, here you can see it is 2. Whenever the value is less than 5, we will keep the number as same. So the final answer is going to be minus 212 kilojoule. Now this is very, very important. Then whenever you enter the answer in that answer box, if a negative sign is present, be very, very careful that you add this negative sign first. Okay, you will get the option of clicking the negative sign. So you first add the negative sign, then you write 2, 1 and 2. In the answer key, if you see, it is given minus 212 to minus 212. So this is very particular. If you write the answer as minus 212.2, your answer will be incorrect. If you write minus 211, your answer will be incorrect. If you write minus 213, your answer will be incorrect. What is going to be the most common mistake? You just write 212 without the negative sign. This is the most common mistake that people do. Okay, so always remember to add the negative sign. So the correct answer is minus 212. I hope you have understood the solution. Thank you.